Carbon, or C, is the nearest element to neon on the periodic table, which is not a gas. Look at the below portion of the periodic table and determine how many electrons carbon needs to become stable. Discuss. Carbon needs to borrow and share 4 electrons to reach the same number of electrons as neon, which has 10 electrons. As a result, carbon makes 4 bonds with other atoms, 1 for each electron it wants. Carbon's ability to make 4 bonds allows it to make a huge number of interesting molecules. Carbon is the basis of all life on Earth. Entire chemistry courses and programs are dedicated to just studying carbon chemistry. That field is called organic chemistry. 2 carbon molecules critical to life on Earth are part of the process that stores the sun's light energy in food molecules as glucose. Carbon dioxide, CO2, glucose is C6H12O6. The process is photosynthesis, which will be covered in more detail later in this course. Another process involves burning wood. We'll use both as examples of chemical reactions. Wood is made up of sugar molecules. The simplest sugar molecule is glucose, C6H12O6. Glucose is made of 6 carbon, 12 hydrogen, and 6 oxygen atoms. Take a moment to make sure you understand the subscripts. Or you could think of glucose as being made of equal numbers of carbon atoms and water molecules. Take a look and see if you can see that. How many carbon atoms and water molecules are there? While it's always written as above, C6H12O6, can you see how writing the formula for glucose as below explains why it's called a carbohydrate, a combination of carbon and water? Carbohydrates are the foundation of food webs. The word is a combination of carbon and hydro. This is the spontaneous chemical equation for burning wood. The wood combines with oxygen to yield carbon dioxide and water. While the reaction is spontaneous, it requires energy to get started. That's why wood won't burn until exposed to a flame. Which side of this equation is stable? Which is unstable? It takes the energy of the sun to turn carbon dioxide and water into sugar and oxygen. It takes no energy to do the reverse, so sugar and oxygen are unstable. But do trees just burst into flame on their own? So wood, or glucose, is like the rock on the top of the cliff. It is ready to release energy once it's pushed over the edge. Where did the energy come from? After burning wood, we are left with carbon dioxide and water. Carbon dioxide is a gas. Water in a flame will form water vapor, also a gas. The result is that the mass of the wood goes into the air. That's why the mass of the wood seems to disappear. The energy to create wood is provided by sunlight. Life has evolved to capture the energy of sunlight and store it as glucose. Glucose is then used to build plants and trees, including our food. And its energy is released when it's burned, or when needed by living cells during respiration. The sunlight carries the rock to the top of the cliff. Photosynthesis takes water and carbon dioxide from the air and turns it into solid glucose and oxygen gas. The trees we see around us got their mass from the air. When you burn wood, the light and heat you see and feel is the energy from the sun, which was used to create the wood. This process of forming glucose through photosynthesis is the basis of almost all life on Earth. What goes into photosynthesis, or the reactants, are water and carbon dioxide. What comes out of photosynthesis, or the products, are oxygen and glucose. Glucose is sugar, a complex carbohydrate containing carbon. The individual molecules of carbon, hydrogen, and oxygen are joined together to make this molecule. Drag and drop the reactants and products into the correct place in the equation. Water plus carbon dioxide gives us glucose plus oxygen.